Hi, good evening. This is Manjunath. Today I am going to start the real chapters of 10th and students. That is first chapter is real numbers. So, what do you mean by real numbers? Real numbers is nothing but it is a collection of rational and irrational numbers. Before that, you should know these basics. What are natural numbers? What are whole numbers? What are integers? And what are rational and how to solve the rational numbers. So, example you take for natural numbers. Natural numbers means the numbers which are used for counting, that is called natural numbers. Then whole numbers means it is also counting but it includes zero. So in this natural number we don't use the zero, but in whole number we include the zero. Integers means it is having the whole numbers and also negative natural numbers. Negative natural means example you take -2, -3 like this. Okay, whole number also and collection of negative integers also. So it's a integers only. Then come to the rational number. Important. Rational number. The rational number is the numbers which are expressed in the form of p by q, where p and q are integers. P and q are integers. If p by q, if q is not equal to 0. The condition is rational numbers. It is expressed in the form of p by q, where p and q are integers, but q is not equal to 0. Example, you can take 3 by 5. 3 by 5. You can take -5 by 6 also, because it is p by q. So p this one q should not be 0. So the condition q should not be 0. Here is 5 is there, 6 is there, negative is also there. That is not considered. So rational number means it is expressed in the form of p by q, where q is not equal to 0. Either it is maybe addition or minus or subtraction, or either it is the number in positive sign or negative sign. Then there are many rational numbers between the two numbers. Example, you take 3 and 4. In between there are also more than many rational numbers between them. Example, I will tell you 3 and 4. So between 3 and 4 is there, no? 3 you multiply and divide by 10. Multiply and divide by 10. And 4 multiply divided by 10. So for this is the formula for finding the rational between the some numbers. So it is 30 by 10. So this is 40 by 10. So that the numbers from the 31 by 10, 31 by 10, 32 by 10, up to 39 by 10. These are the rational numbers of the numbers between 3 and 4. 3 and 4 always means 3, so any number you can take, you have to multiply both numerator numbers by the same number. I take an example 10. So 10 by 10, it is 30 by 10, 4 by 10, 40 by 10. The numbers between these two numbers, 32, 40 by 10. So numbers are 31 by 10, 32 by up to 39 by 10. You can use it. So they ask 6, so you can write any 6 numbers, 31, 32, 33 like that. Then same as like that, 5 rational numbers between 3 by 5 and 4 by 5. Here here only one whole number also. Here is there, fraction is there. So you can do that also. 3 by 5, same procedure. You multiply by 5. So 3 5s are 15. 15 by 25. You take for this 4 by 5 into 5 by 5. 20 by 25. So for both numbers you have to take same numbers only. You can take 5 or you can 10 also for this also. 10 10, here also 10 10. So 3 by 5 into 5 by is 15 by 25, 20 by 20. So that between is the no. So between is the applicable for the 15 to 20. 15 20 means 16 by 25, 17 by 25, up to 19 by 25. So 5 rational number between 3 by 5 means 16 by 25, 17 by 25, 18 by 25, 19 by 25. So it is in between. So 15 by 25 to 20 by 25. Rational numbers means that. Then you take irrational numbers. The irrational numbers is nothing but it is the numbers which cannot be expressed in the form of expressed in the form of p by q, same, where p and q are integers, q is not equal to 0. So conditionally it cannot be expressed in the form of p by q, where q is not equal to 0. Example, you can take root 2 or root 5. So root 2 is an irrational number and root 5 is also irrational number. But if you take the complete square root, if you take like this root 4, it is not irrational number, because root 4 you can put into plus 2 or minus 2. Root of 4 is plus 2 or minus 2. But both these are not the irrational numbers. So irrational number means the square root should be the definite value is the square of the number should not be there. So you can take root 25. So root 25 is also plus or minus 5. So it is not coming in irrational number. So irrational means the root should be not divisible. So root 2, root 5, you can take root 7 like that. So questions will be there. First question, if 0 is a rational number, can you write in the form of p by q, where p and q are integers and q is not equal to 0? They are asking you to 0 is a rational number or not. Check it, 0. So 0, you can write 0 by 1. So it is satisfying the rational number condition. Because here see 0 by 1, the formula is p by q, where p and q are integers, they are, and q is not equal to 0. Here p is 0, but q is not equal to 0. If q is not equal to 0, then only it is a irrational number. So it is rational number only. They will ask like this: every natural number is a whole number or not? Every natural number is a whole number or not? Yes, because whole number includes both 0 and natural number. So every natural numbers. So every natural number is a whole number, because 0 and whole number means 0 and natural number. So it is true. Every integer is a whole number. Every integer is a whole number. So every integer is a whole number. Whole number means what I told: natural numbers and it includes natural numbers and 0. But integer includes negative numbers also. So whole number does not include negative numbers. So it is false. Every integer is not a whole number. You can take this example also. Minus 5 by 6. Minus 5 by 6 is a rational number, but it is not a whole number, because whole number will not be in negative sign, and also it may come in the like 5 by 1, 4 by 1, that, but not in the negative sign. And after this, I think you understood this difference between the natural and the basic real numbers. So next topic is, it is 3 types. One is terminating. Second one is non-terminating, recurring. Then you take non-terminating terminating non-recurring. So what do you mean by terminating and what is non-terminating recurring and non-terminating non-recurring? If you take example for this, terminating means completely divided by it leaves the remainder zero and it is completely divisible. If you take example 1 by 4, so 1 by 4 4 you can divide it 1 1 is there, so smaller number, so you have to take 0 here, so you have to put point here. 4 to the 8 8 4 to the 8 4 to the 8 remainder 2, then you take 0, so 0.2 4 5 is 20, so it is divisible. So answer is coming, remainder is coming 0. If it leaves remainder 0, then it is the terminating number. So 1 by 4 is the terminating. So you can take 7 by 8. 7 by 8. If you divide it, 8 ones are 8 8 is 64. 8 8 is 64. 6 remaining. 60 means 8 7 is 56. 40 remaining. 40 means 8 5 is 40. So it is completely divisible by 7 by 8 is 8. One smaller number is there, so we have to take 0 point. Then 70. 70 means 8 8 is 64. So 6 remaining. Then you take 0. 8 7 is 56. 4 remaining. 4 0 means 8 5 is 40. So these two examples are for terminating. If you take non-terminating recurring. Non-terminating recurring means you take example 1 by 7. 1 by 7. Its value is 0.14 2857. So this is a non-terminating recurring. Non-terminating recurring means it is not completely divisible, and recurring means it is for some numbers it is repeating. So here see 142857. Again here it is coming 142857. So up to this numbers it is coming again and again. So it is non-terminating recurring. One more example you can take 10 by 3. 10 by 3. Here see 3.33. So it is non-terminating and 33 is repeating. 3.33 like that only it is repeating. So non-terminating recurring. And what is this non-terminating non-recurring means? You take example root 2. Root 2 value is 1.4145 means this is different number, and that number is not recurring, means 4 and 5 is not coming again, at least to this 5 6 5 6, that also not coming. The numbers will be non-terminating and also non-recurring. Different numbers will go on getting different numbers, so that is called non-terminating and non-recurring. So I think you understood this three topics with examples. You can take one more example for this. Take value of pi. Pi is 20 by 2 by 7. In decimal value it is 3.142. 3.14 something. So it is goes on getting the number but not repeating. So it is non-terminating, non-recurring. This one non-terminating, but recurring means 5 means 142857. This is repeating 2 times or 3 times. That one. So that is called non-terminating recurring. These terminating and non-terminating, terminating and non-terminating, recurring. So these two will give the answers always in rational number. It gives answers rational number. How I will prove that? This one you take an example 3.33 you take 3.33 you take, okay. 3.33, this is terminating non-recurring. So non-terminating recurring, so we have to prove that it is a rational number. So you take this one 3.30, put x equal for this value we have to put x equal to 3.33 into 0.33. Okay, then multiply it is 1 hour repeating, so repeating you have to take multiply by 10, so both side 10, it will become 10x. This one 10 into 3.33, so it will become become 33.33. So once I will repeat it. You put x as 3.33. That one answer. So multiply both side on 10. This is 10. This is x. Both side 10. So 10 into x, 10 into 3.33. 10 into 3.3 is nothing but 33.33, because it is 10 is there. Multiplication only 10, 100 is there, means how many numbers are there? That times it move the right side. So point is here, so it will move to this one 33.33. So this one we can split as 30.30 plus 3.33. So this one 10x. So what is our taken 3.33 is as x. So 10x 30 plus x. So 10x this term means minus x. So 9x. 9x equal to 30. X equal to 30 by 9. This is 3. So answer is 10 by 3. Check it. 10 by 3 is the rational number. So it is the terminating and non-terminating recurring numbers always come in the it will become the rational number. How much I will check the decimal point you have to take decimal expansion. Then you have to put it as x. Then you multiply how many numbers are repeating? One more. So you have to take 10. So 10 into 3.333. Then you can write 33.33. Then you can solve it by splitting as 30 plus 3.3, because we have taken x equal to 3.33. So 10x plus is equal to 30 plus 3.33. Then 10x is equal to 30 plus x this side comes means minus x, so 10x minus x 9x, then 9x equal to 30, x equal to 30 by 9, you cancel it by 3, 3 3s are 3 10s are, so 10 by 3 is the rational number. So every terminating and non-terminating recurring is always a rational number, but non-terminating non-recurring it will be always be irrational number. You take example for this another example for non-terminating recurring. It is 1.27. Now this bar means it is repeating these two numbers, means 27, 27, 27. It is repeating like this. So it is coming 27, 27. So we can write that number as 1.27, 1.27, 27. Like this you have to write. So it is two numbers are reading, no, because 27, 27 is reading. So you have to multiply by 100. 100 into 1.27. Here put this one as x, 100x. So 100 into 1.27. So 100 into 1.27 means 127.27. So this is 100x. So you can split this one as 126 plus 1.2727. 126 plus 1.2727. Then this one value we have taken as x. So this is 126 plus x. This is 100x. This is 100x. So 99. This one here comes. So answer will be 99x equal to 126. Then we have to cancel 126 by 9. So 9 is a 9. 9 ones are 9, 9 fours are 36. So answer will be 14. 14 is nothing but 14 1. So it is coming now also it is coming in rational number 14 by 1. Answer is 14 by 1. So for this why I have taken 100 means because it is recurring by two values. But this one is recurring by only one value. 3 3 is coming. So it is 2 7 2 7 coming. So two values means you have to take 100. So 100 into x is equal to 100 into 1.27. Then 100 into 1.27 means 2 zeros are there. So the point will move two sides. 127.27. Then 127.27 is written as 126 plus 1.2727. So 1.126 plus this is have taken x. So x 100x minus this x means 19x is equal to 126. X is equal to 126 by 9. This is 14. 14 by 1. So non-determinate is coming always a rational number only. It will come always rational number only. Only non-terminating, non-recurring is always a irrational number. Is always a irrational numbers. So you first you see the difference between these two, which is the rational number, because terminating and non-terminating comes in the values come in the rational number, but non-terminating, non-recurring is always a irrational number because it will values will be like root 2, root 5 like that. So these are the basic examples for the real numbers, but for the first topic for the real numbers in the 10th standard, this is about 9th standard basic is there. So I have taken this one because it's helpful for the your basics, because you should know the rational numbers, irrational, what do you mean by irrational, so like that. Then I move on to the topic, the first chapter of the topic, real numbers. It is Euclid's division lemma. It is called Euclid's division lemma, EDL, short form EDL. Okay. So what is this Euclid's division lemma means? Lemma means the proof. If you prove one statement, that one proven statement is proving for. Actually, I was studying this one. Due to the phone call, it is not clear from this sentence. So I will repeat this once again. This algorithm means first lemma means it is a proven statement used for proving used for another proving statement. Algorithm means it is a steps to procedure for the to do the type of a problem. So it is the major steps. Stepwise it is going to prove the system, prove the problems. Then Euclid's division lemma is on one formula, that is dividend is equal to divisor into quotient plus remainder, where a is a positive integer is equal to b q plus r. Is a is q is nothing but a quotient, remainder is r, and divisor is b, and dividend is equal to a. On this method, you take the formula for this. It is 455 and 42. 455 and 42. So you have to take first smaller number in the divisor place, so 42, and 455 is the dividend, 455. 42 into 10, 42 ones of 42. So remainder 5 is 3. Then 5 is there, 35. 35 is smaller than the this divisor. So when it is smaller, you have to put 1 0. So 42 into 10 plus 35. Remainder is 35. So this is one step. Then this step will be continued up to the remainder should become 0. So next step what is the smaller number except the quotient. This remainder you have to take, and divisor you have to take. Divisor will become the remainder will become the bigger number will become the dividend. So 42 is dividend, 35 is remainder is there. It will become divisor. 35 so 35, 7 is remaining. So in this problem, then you have to continue because 7 is remainder. Then 7 is there, 35 is there. So 7 and 35 is there. 7 is the divisor will become, and 35 will be dividend. So 7 5 is 35. The remainder will be 0. So 7 5 is 35. So the remainder should be zeros, then only this Euclid's division lemma is stopped there only, and that last divisor is the HCF of the that given numbers. So 455 and 42. So I hope you understand this topic. I will continue these problems in the exercise on the next class and tomorrow. So thank you. Please subscribe my channel. My channel name is Manjunath Shungi. I hope you are understanding the topics and you can repeatedly see the videos and you can understand better way. Thank you.